Good morning, good afternoon, and good evening. I see more than 400 people logging in today's session about a digital twin for telecommunication networks. Today, we will showcase you our solution on how to bring your network to life. My name is Luc Dehaene. I'm the Chief Commercial Officer at Merkator, and I have the pleasure to invite three of my colleagues for today's session. First of all, Chayun Zhu. She is a fiber specialist working on the Marlin solution. Secondly, also Bart Stuykens, a senior telecommunication expert with more than 20 years of experience in the telecom industry. And last but not least, Geert de Koensel, over 35 years of experience in the geospatial arena, but also the CEO and founder of Merkator Belgium already 10 years ago. Today's session, it's about defining what is a network digital twin and why you need one, and talking about the benefits it enables for telecommunication operators. It is not a pre-recorded session. We will do real demonstrations of our software, and we will focus on fiber workflows. Although Marlin can take on multiple types of utilities, it will be focused on fiber today. And of course, we will focus on the complex integration between the physical infrastructure and active equipment. Towards the end, we will talk a little bit more about who we are, and there will be room for Q&A. Just a small practical announcement, this session will be recorded. We invite you to ask questions during the session using the chat box on the right-hand side of your screen, and using the brackets on the bottom of this video, you can make this a full screen experience. Today, network operators face important challenges with the adoption of new technologies like 5G and the need for more fiber closer to the consumer. But also the promises of network orchestration and automation are quite interesting. But many operators are struggling to adopt these kind of new technologies because they don't have access and reliable data to make the right strategic decisions. But also in the execution, even today, field engineers arrive on site with a work order documentation that is different from reality. For example, they have to connect a new consumer to the port, but in reality, the port is already connected. Who is connected to this port and what services are running on top of it? It's quite a difficult decision for the field engineer to make. Hopefully, the information is available within the organization, but maybe for different users, maybe in different applications, and it's not already available in the field. In order to make the right decision, it could take up many hours to find and deep dive into all these applications, and even going through sometimes Excel files where people are still relying on spreadsheet information to document and maintain the network configuration. And this is really the big struggle to adopt a digital twin. Why do you need a digital twin? Well, in order to enable operational efficiency for these teams. So both in the strategic decision making, but also in the planning, the design, the construction, the operation and support, every day, those teams are facing the impact of data quality issues. And by bringing high quality data and making it available for all these teams, we can enable operational efficiency by the concept of a network digital twin. But what is a digital twin? Well, it consists out of three elements. First of all, of course, it's a digital copy of reality. It's a virtual representation of your telecommunication network. So we're talking actually about inventory or documentation. But it's more than that. You also need continuous feedback from reality to update your documentation. You need to have sensors in the field that take on the data to feed it to your virtual representation to make updates and increase the level of accuracy of data quality. And why do you need this eventually? Well, if you have a high quality copy of your reality, you can make network simulations. You can simulate the behavior of the network. For example, what happens if a cable breaks, if equipment dies, which customers are impacted, which services are impacted. But also, where do you need to expand the network with fiber to the home or with your base stations for 5G? You need to have accurate and reliable information to make these business decisions. So if we look at the first part, it's a digital copy, it's a virtual representation. What do we mean? For a telecommunication network, it's quite complex. First of all, you have the physical inventory. So the ducts, the cables, the fibers, the splices, the splitters, and so on. Typically, these are documented in a GIS solution. But in order to create a connection between all those consumers you need to have equipment in the field. OTN and WDM networks, but even legacy solutions are typically in place as well at the older and bigger operators like PDH, for example. And when you have the physical infrastructure and the active equipment, you can bring a mobile connection like 4G and 5G or internet access, coax or fiber towards your consumers. So if we talk about a digital copy, it's important that we not only document the layer on the bottom, which is the GIS, but also the active information, the active inventory. How do we do it? Well, we can directly probe your network, or using a node-bound interface, we can catch the information from all these systems and equipments in the field. We will normalize the data, and through the technique of layer stitching, we will integrate all these layers together to come up with a complete end-to-end view over the different layers in your network, over all the vendors you have in the network, to come up with this complete view of your telecommunication network. And what's now the cool trick, why can we call it a digital twin, is that this process of the taking the data, normalizing the data, and stitching it together, this network mining process, we do it each and every day. And that means that we take the actual state of your network and feed it to the digital copy in order to detect data quality issues. And we do it every day, so it's always up to date, it's accurate, it's complete, and also quite interesting, it's a maintainable process because we automate this whole process each and every day. Now, enough theory, let's deep dive into the first demonstration, and I want to invite Jayun to this session. Jayun, can you show us more about the physical inventory solution of Marlin and how we enable data quality when designing the network, for example?
Yes, Luc. Thanks, Luc, and hi, everyone. So I'm going to do the next part of the demonstration. But first, I think we can all agree that it's so important to have a reliable physical inventory for planning, operation, and support, right? But the question you may have is, how can we ensure that? How can we make sure to have accurate and clear data we can rely on? Well, that's what I'm going to show in the next couple of minutes with the Marlin inventory. First, we will do a geospatial discovery of the fiber infrastructure. We will browse through trenches, racks, connectivity, and much more. And you will see a series of insightful schematics, including the butterflies. Now, not this kind of butterfly you see on a PowerPoint, another kind of butterfly. But it's so insightful, so make sure you don't miss it out. Second, I will show how to connect a new customer to the fiber network using the Marlin flows. You will see how those flows ensure high data quality and so produce data you can rely on. Let's move to the demo part. So what do we have here? We have Marlin working as an add-in in ArcGIS Pro because it's an Esri-based solution. We have on the map our fiber network. Now, if I select one of those brown lines, which are trenches, I can see its information at the bottom. I see its attribute, of course, but also its cross-section. Now, this view shows me the content of the trench. It shows me that this trench contains 3 ducts. The 2 on the right have inner ducts, and they all have fiber cables represented in black. Now, this view is dynamic, meaning I can, for instance, select a fiber cable, see its extent on the map, and also extra information, including the light paths and the customers they serve. Same goes for the duct. For instance, if I select this one, I will see its extent on the map. I can also zoom to its entire extent. Now, if I'm curious to see what's at the end of this duct, I can select this manhole, and that's where the butterflies comes in. This very insightful schematics shows me a view similar to the cross-section view, but with the additional information about the fiber cables and the connection between them. In this case, I have 4 fiber cables connected to a splice closure. And there's more, because you can open the details of the splice closure and browse through its internal contents. For instance, you can see the number of trays it contains and also which fiber conductors are on which tray position. You have the information in a tabular form, but also in a graphical form. Now, all the schematics I've shown you until now, all those graphical representation of your physical inventory, they are automatically generated in Marlin during the design. So now I'm sure you're getting curious to see how those schematics are automatically generated. So let's do some design. Let's connect a new customer to the fiber network. Now, designs in Marlin are done within an edit session. That's actually for better data management, because we don't want our incomplete design to interfere with master data, right? So I'm going first to activate an edit session. As I activated it, you will see that the system brings me to the area of interest. And there is a red shape here indicating the extent of my design area. And also see some ongoing designs, including this building and access point. So what I'm going to do is to dig a trench and connect that access point to the butterfly that is here. To that manhole that is here. And I can see from the butterfly view that this is for the moment just at the intersection of 3 different routes with different contents. Yes, so let's do some design and draw that trench. To do that, I'll use a flow in Marlin called create route. Now, the idea behind those flows is that they will guide me step by step to complete the design. And whenever my input as user is required, I will receive a clear instruction. So this step, I need to draw the trench on the map. Also, at each step, there are also validation checks to ensure the quality of my design. So in case I did something wrong, I will need to start again. Also, something very important is that the flow contains always also some automation to speed up my design. And in this case, for instance, it suggests me to pick a template. So what is the system doing here? It notices that I'm drawing a trench, and so it says, you're drawing a trench, maybe you want to put some ducts along. If so, please select one of those templates. And I kind of like the idea, and I will pick a DB2, which is a duct with 2 inner ducts. I click on next. I can check the attributes for that trench I just draw, but I can already see the cross-section view. So the schematic was already generated on the fly. Now, if I go back to the manhole and check the butterfly view, I will see that it's also automatically updated as well. So now it takes into account the new trench I just drew. Next, what am I going to do? I'm going to blow a cable from the rack that is located within the building all the way to the manhole. I want to have a continuity between the inside plan and the outside plan. So you may have the question and ask, but how do I know what's in the building? Well, in Marlin, we also manage the inside plan view. That's what I'm opening up. And you see that in this case, I have a building with 3 floors. I have the access point here, and there's a path connecting to the rack on floor 0. And I can select the rack to check extra details. It's the same principle as the splice closure I showed you earlier. you can open up its details. In this case, I have a shelf with 2 different trays and a cart. And same idea, I can show the graphical form of it. In this case, I also see some pigtails between the tray and a cart. So let's blow that cable from the inside plane to the outside plane. So to do so, I'm again going to use a flow in Marlin. Same principle, it will guide me step by step. I first need to select a starting point. I want it to be inside a building, and the end point I want it to be on the map, all the way to the manhole. In this case, no waypoints. Automation process. Do you want to choose a catalog item for the fiber cable? Please, yes, please. I pick this one. And so in the background, the system will create automatically the fiber cable with all its bundles and fiber conductors. The next step, the system is asking me, okay, actually on the segment, on the path you chose, I found some ducts. Do you want to place in them your fiber cable in them? I will say yes and choose the container. That was for the inside plane, and I have the same choice for the outside plane. In this case, if you remember, I just placed a DB2 with 2 inner ducts, and I'll choose to place my fiber cable in the red inner ducts. I go next. I can check the attributes. I just finish the flow, and you will see again, let's pick the access point this time. And you will see also in the butterfly view that it's updated, and I clearly see that continuity from the inside plane all the way to the outside plane. So next thing I want to do is to connect that fiber cable to the rack, right? So in my inside plane, in the butterfly view, I'm going to select the fiber cable I just placed and the rack, and I say, I use again a flow, please connect the fiber cable to the rack. Here I have a pop-up for automation. Do you want to complete automated fiber connection? Yes, please. And here I need to just to fill the form, selecting the bundle I want to connect automatically to which tray, and the number of connection per tray, and the type of connection. I just click on next. And if now I browse again the content of that rack, expanding it so it'll be clearer. It has the 2 trays, right? Now I see the fiber connections in the tabular form, but also in the graphical form. So those fiber connections were made automatically thanks to the flow I used. Now I can repeat the same action on the other end of on the other end of the fiber cable, do some splicing, and also generate a report. But the principle will be the same. Meaning I will be using flows that will guide me step by step to complete the design. It has validation checks and automation, including, of course, the creation of those insightful schematics. And all this will provide you with an accurate and clear representation of the physical inventory on which you can rely on. Now, my presentation ends here. I hope that you enjoyed it. And I'd like now to introduce you to my colleague, Bart, for the next part of the demo. Bart, the floor is yours.
Thank you, Jeroen. It was an excellent presentation. Hi, everybody. Thank you for sharing the slides. I will be I have the honor to present to you the digital twin Marlin part. I'll be talking about simulation of the actual network, where I will be showing root cause analysis, single point of failure, incident simulation, going into some roadworks, what happens there, but also how to build a reliable data source, which is at the end essential for a digital twin, that your data is the best possible data that's out there. Before we go into that, I'll take back the slide from Luc and talk a little bit more about digital twins. So what Jayun just showed you was an inventory of all the physical information, the trenches, the ducted cable, coax, even transmission, wireless transmission would be possible. Now, the question what you want to answer with your digital twin is, how do you connect your physical infrastructure with your customers and your services? What happens if a fiber breaks? What happens if you extend the network? What is the impact on your network? Between these two layers, there are a lot of additional components to be filled in before you can actually determine what will be happening if you touch the physical network. So due to the network mining solution, we built probes that collect the data from the network. We usually start with the transmission layer, where your WDM, your OTN networks are, your wireless network, and for certain as well the legacy devices, SDH, PDH, and there might be many out there still using other technologies. After the transmission layer is added, we'll get out to the network, go to layer 2, layer 3, consistent of your core and access network. Typically, the core is these days in MPLS, the access network is Ethernet. And then finally, this will enable the application like a mobile internet access, virtual private network, cloud access, voice, and so on and so forth. Now, all these components need to be in place before you can actually determine the relation between your physical network and your customers. But so far, we have only collected different islands of data. The final step that we need to do is to interconnect all this data. And network mining has been doing this for 20 years. We have extended experience with getting the data out of the network directly from the devices or through northbound interfaces, and then using advanced techniques to layer stitch the client layers to the server layers. And only at this moment, when all the islands are interconnected, integrated into one overall view, it's possible to unlock the real value of a digital twin. At this moment, we have nothing but a full view of the entire network, which is tremendous. But what you really want to be able to do is incident simulation, where we simulate what would happen in this network if somebody pulls out a fiber, if a trench is cut. Typically, this is used in your plant works preparation, where you want to know 3 weeks, 4 weeks upfront what will be the impact of doing certain change in your network. This is extremely important, because if you can reliably predict what will be the impact, you can be confident in changing your network. Nothing is as bad as trying to make changes in the network, but you're not aware what will happen. Things will go wrong, and you're stuck with the situation. The next step after being able to update and maintain your network reliably is to do a SPOF analysis. SPOF stands for single point of failure, and it indicates where are the weak points in your network, the most vulnerable points. It could be that there is a certain trench, if that would be cut, that a lot of data a lot of connections are lost. It's important to be able to identify these weak points in your network upfront and design solutions around it so that to fix them. Again, this is proactive working, making sure that issues are detected as quick as possible. And finally, when things go wrong, the reverse action happens. You need to do a root cause analysis. A root cause starts with a group of alarms, a number of services that are down. Hopefully the customers are not yet complaining, but it's a hectic moment. At that moment, you need to be able to rely on your data in your inventory systems, You do not want to go to different Excel spreadsheets. You do not want to have different people involved in getting to the root cause. It should be as quick as possible so that you can restore the network back to a normal situation. Only if you have all these components in place, integrated view, accurate and up to date, then it's possible. And as an additional benefit, by integrating all these individual components, you will see where your data is not 100%. And by monitoring your data quality issues and fixing them, you have a continuous improvement to a better data. Good. Enough of that. I'll jump now in the live part, the demo. Again, a small reminder, if it might be interesting for you to put your screen in full screen mode by clicking on that symbol in your right bottom corner of the video. Good. I'll start with where Jayon left off. What you see here is the web interface of Marlin Navigate, of Marlin. It's the counterpart of the editor, which is a desktop application, but all the same information is actually available. It's very important to distribute information through your organization. Here you see a small part of the network. You can click a link. It will load the properties. And you see this one trench, 3 cables in this particular trench. You can select any cable. It will log the properties of what's inside. And here you see that in this particular cable, there are a number of light paths, fibers and a number of light paths. And the magic now happens when I click this network mining button. It will jump into the digital twin for the telco part of the network. As you see here, it loads the application. It's a light path between 2 ODFs in different buildings. And I can jump back into Navigator as I want. Let me just put this a little bit aside, like this. And if I click on View in Navigator, it will actually display the end-to-end light path. Similarly, I can also do the same thing for just any object that's loaded here. So I see this is a light path between the site Hamme and Note Meunier. I simply right mouse click on this link, select View in Navigator, and it zooms to here. This is quite normal. We're showing physical data at the bottom and physical data on the top. Interesting part comes now when we start browsing into the telco layers. In the usage tab, I can see that this light path is actually used by a CWM8 system. You can see here, which is filled for almost 50%. Now, at this moment, I start browsing into the telco part. It's integrating the active and the physical network. This particular OMS link is between 2 OADMs. And intermediate, you see the 2 ODFs and the individual light paths that are being used. It's a bidirectional OMS link that's used over 2 individual fibers. Again, I can move 1 layer up and click, for instance, here on the optical channel. I go 1 level up, click into the audio 2. Now we're in a 10 gigabit connection. Click 1 more level up. We're in audio 2, 10 gigabit, and why not go 1 level up more? So the demo that I'm showing here today is a limited set of data. There's only some OTN network, but in a real network, we can move into the IP layers and so on. What you see here now is a circuit end-to-end between Hamme and Bank. And I can project the actual physical routing back into Navigator. Quite simply, let me arrange my screen. It's always useful to have This is more impressive if you have 2 screens, but it works like this as well. So if I click View in Navigator, what you see here is a projection of all the light paths that a particular circuit at a certain layer in your telco network is using, all the resources from A to B. This, I think, is quite exceptional, that you can simply link all the telco network with your physical network. Good. Apart from linking between the two applications, you also get additional benefits that show. Let me just take the right screen here. Yeah, that's the one. So the network mining application will also build for you schematic overviews of what you have in your network. For instance, here you see not a geographical view, but a logical view of how many light paths there are connected between the buildings that are selected to be viewed in this view. Between these two locations, there are 4 light paths, while here you have 2, and so on. You can see it also more detailed, where individual light paths are shown, or part of the network. This is, for instance, showing the OTN layer of your network. Good. Now, at this moment, I would like to move into the first part of the digital twin usage, namely incident simulation. This is where we're going to use the information of the physical and active network together to predict what will be the impact of a certain change in your network. How does it work? Very simple. You select a certain trench that will be impacted, and then I trigger from Marlin Navigator the incident simulation, and this will then process the information and send the information further on to the network mining part, where you can add more additional telco information that will be added. What we see here, there are 5 individual light paths selected. When I click on the Go button, we will actually simulate the real behavior of a network. We'll simulate what is the combined error in your network by looking at all the individual configurations in your network and doing a simulation of what would happen in a real network. And what you see here is a number of services that are impacted. In fact, there are 19 trails impacted, and that's quite normal because none of them have protection, so all of these are directly related to the link I selected. There are 4 links here impacted, not impacted, they're switching, so they're surviving, but they're losing protection. It's I could, for instance, look now back at one of these circuits, take this one, view in Navigator, and in fact, this circuit is on this part of the network, so it's normal that it's impacted. Yeah, there it is. This is the audio 2 that is routed from here to there. There is no protection. We have cut here in the network, and there is an impact. If I switch back to the incident simulation, I take a protected circuit, and I click View in Navigator. It will now highlight the circuit end to end. So here you see that when we cut this link, in fact, that circuit takes the full ring as a routing, so it has a backup in the other direction, and it's not impacted. I'll do quickly a second link, because you can not only select a single trench, but also multiple trenches. So here I select, for instance, all these 4 trenches on that crossroad. Again, go to incident simulation. Oh. Try it again. Yep. simulate all the behavior in the network, and here we have an updated view of the list. So it works very quickly and quite painless. The second part of the presentation, I'd like to show you the root cause and the protection analysis. So I take here a particular circuit, and it's a protected circuit, so it offers redundancy for the customers. And from the telco point of view, it's perfectly protected. There are no single point of failures in this. However, when we run the analysis, it's shown that these are the single point of failures. Now, the first 4 are normal because these are the start and the end equipment and the ODFs in the building, hard to avoid. But then the application has detected a number of shared risk groups. And the shared risk groups indicate that if that particular trench is down, then the circuit will be impacted. Now, this kind of analysis you would run daily, and as soon as a circuit is delivered, you can check, is it delivered according to standards? Is it sufficiently protected, or does it have single point of failures? We can now investigate what is the particular problem with this circuit. So if I select one of these shared risk groups, go back in Marlin, try that again. So I'll take the particular trench. Yeah, okay. So it says that this particular trench is a problem for that particular circuit. Now, we can only investigate that by looking at the end-to-end routing of that circuit. So, and you will see that that circuit is actually terminating on this particular link, and there is no physical diversity, which is easy to detect if you look at that part of the network directly. But if you have thousands and thousands of circuits in your network, you want to have an automated detection of that particular issue. Good. The final part is root cause analysis. What to do when a problem actually appears in the network. For that, I've prepared a little situation. So the incident root cause analysis will start from a given set of services that are down. And actually, we're here on a demo platform, so I'm not linked to a real network. I will select a particular scenario. Good. It's loaded. Which operator can do also manually. In this case, there is a group of circuits that are impacted in the network. And the question is now, what can explain this? Clicking on the calculate button makes a reverse incident simulation, and it will try to figure out in the network what can explain the combination of these errors. And actually it found 3 different possibilities that explain that exact combination for 100%. There are other ones, but they explain only partly the combination. So the most obvious root cause is one of these 3. Now, that's already a big reduction of where to look. And we can see in Navigator where these trenches actually are. So the first trench is this one. I'll see where that's located. It will highlight it in Navigator, and it's actually this particular section. Now, we know now physically where it's located, but what is really cool now is that we can not only integrate the telecom data and a physical fiber network into your Navigator, but as well enable external services such as a HIPOD. For instance, that's a service in Belgium that is obliged by the government for every company that works on the public roads, they must submit where they will be working in a certain area and for so long. And by enabling this layer, I load in the data. And what have I noticed? There is an effect. This gray rectangle indicates that there is a company working in that environment. And by simply clicking on it, I can get to the contact details of this company and investigate or call them directly to see whether an incident has happened to that. This shortcuts the time to do root cause analysis enormously, because all of this can be done by a single operator working in the NOC and does not need to involve many people in the field or in different departments. You don't need to go to your level 2, level 3 experts of your telco network, IP or transmission. Now, one person can do this, and this reduces the time to find the root cause enormously. Good. With this, I'm done with the demo. I thank you for your attention, and I will give back the word to Luc.
Thank you, Bart and Jaime, for the demo. I think it was a quick demonstration. We don't have the time to go over all the details of our solution, but I hope it was clear that our Marlin DT solution offers a complete view of your network. So it's end-to-end over all the layers of a telecommunication network. We also have an up-to-date view of your network that is very accurate because we probe the information directly from your devices. And as Bart explained, it's also very maintainable. You don't need extra teams to deploy this situation and to elevate data quality. It's always a big struggle for an operator to do it. With this process of these two solutions of the Marlin DT offering, it's actually quite maintainable to implement. Without further ado, I hope you're still interested to know who we are and what we do. And so therefore, I invited Geert de Koensel, over 35 years of experience in the geospatial arena, and a CEO and founder of Merkator Belgium. Geert, can you take the stage and talk a little bit more about who we are and what we do?
Thank you. Thank you, Luc. First of all, thanks to Luc, Chayun, and Bart. You did a magnificent job a while ago. It's always scary to talk to a camera, knowing that there are 400 people at the other side. This last hour is not the work of 3 people. Directly or indirectly, there are about 90 people of Merkator that are involved in this process. As you can see on the picture, we are situated in Europe, and more specifically, we have the roots in the Netherlands and Belgium. In 2019, we started our first office in Spain. We have a sales hub in the UK. And during the difficult 2020 COVID year, we actually started doing business development in the Middle East, where we have our first partners. And we also have our first partners in the US, and actually also our first customers in the US. This is for me also the moment in time to say to the audience, because I know there are at least 40 geospatial companies in this call, that we are actively looking to partners that are in similar business, geospatial, telco, smart grid related. So reach out to us after this session, because we are eager to talk to people in different countries as soon as possible. If you look at the slide on the right side at the top, you see our main Marlin Digital Twin references. The most noticeable one is Telenet, because it's related to one of the questions of John, who asked if we have experience in scaling up to a major telecom provider. I think that's a good example. It's a tier 1 next to Proximus. It's the tier 1 telco provider of Belgium, and they scaled it up to use throughout the entire enterprise. And I'm talking about Marlin, the inventory part, and Marlin, the digital twin part. In the bottom section of the references, you see other customers where we provide professional services. That's also customers that still use several legacy systems, but that are also eager to know more about our Marlin roadmap. That brings me to another type of asset, and personally I think that's a very important slide. Try to understand it. It's not that difficult, but I'm convinced from a professional point of view, but also from a personal point of view, that time is my and your most precious asset. And time is a very important component if you talk about digital twins, because the more time it takes between a change in the real world and the update in the digital world, the less chance you will have to have a true digital twin. So the purpose with our software innovation is to shorten that time. Processes that sometimes take months, we will reduce it to weeks, and weeks to days, and days to hours, even seconds, if you talk about real-time probing of the network. So the purpose of this curve is that you move upwards, not the way you see it now, because then time becomes your disadvantage. The purpose is, as it's going to bounce now, that you try to reduce the time, because we all know, especially in business, time is also money, and at the end of the day, that's an important parameter as well. Explaining the Marlin ecosystem, we will not do this in this webinar. There will be future webinars in the weeks and months to come. What's important to illustrate here is that Marlin consumes a lot of data that is resided in a database. But if you look at the right side of this small figure, we have the software and innovation to also talk directly to the network. And that is what it makes really unique, because we fetch the data from the network. So you cannot be closer to the real world than really capturing the data in real time. At the top left, you see that the geospatial component is really important. The system that we have built, it runs on ArcGIS Pro. There is a question of FIMI, who asked, will the software also work on MapInfo, or does it only work on ArcMap? It actually doesn't work on both today. It used to work on ArcGIS-Map, but that's for us also a thing from the past. It only runs on Esri ArcGIS Pro, and of course at the back end all the other Esri GIS server components. And that brings me indeed to the final one. There is still 7 minutes left for some questions. I tried to answer 2 of them. And yes, I want to reroute some of the questions to some of my colleagues who are in the call right now. Luc, can you take the question from Jolan? And how do you deal with surface types to dig through, or different obstacles blocking the trench?
Yeah, thank you for this question. I think when we talk about planning new FTTH connections, for example, it's important to estimate the total cost of rolling out the fiber. Why is this cost parameter so important? It is to make the right decisions. And for example, using information about road types, taking into account the width of the road surface, or the type of surface at the edge of a road, is very important for algorithms to reduce the total cost of expanding the network. And therefore, we rely also on partner software, for example, to automate the FTTX design that can perfectly take this information into account.
Thank you, Luc. There is a question from Tintin Madayak. What is your estimated Opex savings to the telco using this tool? The savings, according to us, it's all about that data quality. And if you don't have the data quality, the time, again, think about that paradigm with the time slot, the time you will lose as an organization by running from one department to the other, just trying to fetch the right information. So only improving the quality level with 5 to 10% could have a 200% return in terms of Opex. And we know it's challenging when we talk to a lot of telco operators, because you also want to break some walls that have been created within those bigger organizations, that the transmission department and the engineering department and the customer satisfaction department, they have connecting systems, but they have their proper P&L, and it's not always easy to bring them together. But it's an interesting discussion. We like to do it, and we are sure that it's not a matter that the system is costing you money. No, it's saving you time, so it will save you money. Do we have other questions? There was another one from Tintin about if we could use the tool also for some use case for mobile network coverages. And there we are happy actually to be able to use the full potential of the Esri ArcGIS Pro environment, because it's capable of helping you not only for some 2D workflows, use cases, but also three-dimensional use cases. So if you want to calculate line of sight and those workflows, you don't need to invest in another system to do this. You can just rely on the same desktop application that you use to configure or to work with the Marlin environment. So remove the number of different systems you use to stay consistent and indeed to have that ambition to go for higher quality. There's an extra question from Ron Brandt. Can we, via APIs, expand and customize to customer requirements? I would like to push this to Olivier Damanet, who is our CTO and should also be in the call somewhere. Olivier?
Yes. Not only we can adapt the data model to the customer specification, because the data model in our Marlin's DT solution is fully configurable, but also all the use cases. So in Jayun's demo, you could see those flows which guide the user in the different steps. All those flows, they are fully configurable in our application, which means that you can add some step in the flow based on your requirement, or remove some of the standard set of the standard Marlin functionality if you don't need it. And also the implementation is also extendable if we have on an open API, so that you can also customize some of the logic in Marlin, even the screens, the dynamic views that you saw during the demo, you can make your own.
And I think on top of that, Olivier, how open is Marlin?
The database is fully open. We support both Oracle and SQL Server, and it's really fully open, so you can also interface directly at the database level. And for the implementation, we use .NET Standards, which is really the most usual coding platform at the moment.
Thank you, Olivier. There is a very interesting question from Sayed. I hope I pronounced the name correctly. The question is, what's the main benefit for digital twin network? And can we use AI? I think you mean artificial intelligence classification. Perhaps Bart, you can tell something about the prototype we built around AI and automatic label recognition, our Fiber Vision prototype. Bart?
Yep. So the prototype that we built is actually using a video and photo material from different locations, from different sites, where we recognize labels and ports, so equipment usage, and patch cables directly from a picture. And the purpose is that you can, using the AI, the machine learning layer, that will automatically recognize the different components in that picture, and that's it will be used as a feedback system into your database to further increase the data quality. But it's also used for, or it will be used because it's still a prototype, for connecting the field engineers to the information in the management system. For instance, a field engineer will be able to take a picture or just hover over a certain label in the field, and it will pop up automatically the right data on your screen relevant to what he's looking at, and the data is then coming from the Marlin system itself. That's in very short the AI, the machine learning project that we did for fiber vision. In terms of what we show today, yeah.
Yeah, please proceed.
Yeah, so in terms of what we show today, there is no machine learning itself, and the reason we think is that most of the telco data inventory systems, if I can call them like that, out there, they suffer a lot of data quality problems. And the first problem to tackle is to get your data into your network and then use that data. And it's a lot of things in a telco network are quite deterministic. Meaning if you pull out a cable and you know what are the configurations in your network, you can predict what will be the impact. There is no fuzzy AI learning logic necessary at that level. Where it could become interesting is where you need to integrate two layers, two data islands together, then and you need to interpret naming conventions. There it can become more interesting to use it, but also on that part, usually it's quite deterministic.
Okay. I have another question. Thank you, Bart. I have another question from Willy. What's the largest deployment currently in terms of kilometer of fiber? Yeah, I have to come back to the Telenet case, which is actually a combination of fiber and coaxial, so electrical driven connectivity. The network there is 67,000 kilometers. Is this a lot? For Belgium, it means more than 60% of our nation. So for us, it means a lot. But I don't know where Willy Govender lives. But hopefully that's the right answer. So a little bit less than 70,000 kilometers of network. Yeah, I noticed that we are past the hour. Coming back to my statement of time, we need to respect it. We had 1 hour for all of you. If we count 400 people, that means 50 man days we just spent all together to learn about Marlin Digital Twin. I would again end by saying thank you so much for attending. There will be more webinars in the months to come. Some of them will focus on the inventory part. Others will focus on the network mining part. Stay tuned. We have a very simple email to reach out. So marlin@merkator.com. Wish you all a pleasant day, a pleasant morning for the people that just dialed in from the US, and a pleasant evening for the people that dialed in from India. And with this said, I will sign off, and also thanks the organization Geospatial World for the excellent support they provided us over the last couple of weeks. Thank you so much. Bye.
Bye.